Okay, good morning, everybody. So I've had two requests for problems with this week, so I'm going to start with those. And if you come across any other ones that you want me to go over, just let me know either in chat or if you're not logged into YouTube, you can also just send me an email because I do have that up, so I can check both of those. Okay, so starting off, here are the kind of the summary of the topics of the day. So we talked about finding inverses, how logarithms and exponentials are inverses of each other. So just to kind of give you a quick summary here, it's very similar to, if you remember, we did stuff like, I don't know, like x squared plus 7, right, equals y, right? And if I asked you to find the inverse of this, right, we would do a quick swap and we'd say make x y and make y x. So it'd look like y squared plus 7 is equal to x, right? And then I can just get y alone again, right? So I'm going to subtract the 7 over. It'll say x minus 7, right, equals y squared. And then a big square root over this, right, on both sides. So it would be y is equal to plus or minus the square root of x minus 7, right? So this is kind of what we did with inverses, like way at the beginning of the year. And the idea was that because squares and square roots cancel each other out, and they're opposites of each other, that we can turn one into the other and say basically that this expression at the end will undo the original expression at the beginning. Okay, so the connection to what we're doing now with exponentials is that the exponential expressions like 5 to the x plus 1 plus 7, right, it has an inverse. It has something that undoes it. Okay, and the inverse is going to be a log. Okay, and so what we said for problems like this was that, remember, f of x is really y, so I'm just going to kind of like pretend like that's y. We're going to do the exact same thing that we did with our old inverses. We're going to swap x and y, so it's going to say something like x equals 5 to the y plus 1, okay? And our job is going to be to get y alone again. Oh, that's a plus sign, not an equal sign, okay? To get y alone again, right? And that's a little bit trickier, right? Because we have to figure out how to make this not an exponent anymore, right? It's currently an exponent. So what I'm going to do is start off by subtracting the 7 to the other side, and we're going to make it x minus 7, okay? And then what we said was, at this point, once this exponential is alone, we can convert this into a log, okay? So I'm going to, again, just do a quick reminder for you down here, because I know all this stuff kind of blurs together after a while. We said that if I had something like, well, we'll do it from exponential form, so let's get rid of that, okay? If I had something like 2 to the third is equal to 8, I can convert this into a log by saying that a log with a base of 2, and then I'm going to take the log of that answer 8, and then the answer to this is the exponent, which is the 3. So if you notice what happened when I made this conversion, what used to be an exponent, right, this 3, is now not an exponent anymore, right? It's just the answer to the log problem. And so this is how we're going to get things out of when I need to like solve for a variable that's in the exponent, the way that we get it out of that is to turn it into its log form, okay? So if I do that with this problem, I'm going to do the same thing. I'm going to say log, okay? And the base is 5, okay? The answer to this, right, kind of like the 8 over here, the answer is this x minus 7, so it's log base 5, and I'm going to put a parentheses just to make it clear that all of this is the answer, not just the x, okay? And then the answer to this is the exponent, right? So the 8, the 3 was the exponent, and that became the answer. Well, ours is y plus 1, okay? So I'm going to say y plus 1, okay? And then this is something that I can very easily solve for y now. All I need to do is take this plus 1 and subtract it to the other side, and it's going to say the log base 5 of x minus 7 is minus 1 is equal to y. Okay, so if I were to ask you what is the inverse of 5 to the x plus 1 plus 7, it would be this thing. Right? Essentially, if you were to take any answer that popped out of this thing and plug it into this log expression, you'd get back to where you started. You get the x that you plugged in initially would come back out at the end. Okay, so that's inverses. And again, there's a lot of variation on this. So if you have any issues with any of the other problems, just let me know, and I can do that for you as well. Okay, so this is the inverse one. This was what was due on Wednesday. So hopefully you were able to tackle this one pretty easily. If not, you can go back and make some adjustments, and I'll take a look at it next week. Okay. So here's the second problem, and this is the log properties, okay? And so here's your quick summary of the log properties, and there were really just 3 of them, okay? So here they are. Hey, we'll summarize them over here. If I have something like log of xy, right? And it doesn't matter what the log here. Like I'm just gonna leave it blank, assuming it's a base 10. But if I have something like log xy, I can expand this and turn it into two different logs, right? One containing the x and one containing the y. And the way that I'm going to do that is to put a plus sign in between them. So multiplication, right, inside of a log, when we split it up into a log x and a log y, we're going to connect those. Now we call this the expanded logarithm with a plus sign. Okay, so multiplication between parts becomes a plus sign. Okay, if I had something like this, right, so that's the first property. And by the way, this goes the other way too, right? So I can take an expanded expression and put it together into one, right? Actually, if I bring it up, the homework that you guys had. Let me see if I can find it. Log properties. Okay, this homework assignment. Okay, some of the problems asked you to write it as a single logarithm, which is condensing it down, right? Using the properties to put them all together into one log, right? The ones down here, the one I'm about to go over, is expanding it, which is starting with one log and turning it into a bunch of separate ones, right? So this is a reversible thing. I can go from one log to many, or from many back to one, as long as they have the same base, right? Which all of these problems will. Okay, so the first property was multiplication inside of a log becomes addition if I expand it. Okay. The second one is if I have something like log of x over y, right? So division, right? The fraction bar is division. It's going to be the same thing. I can say this is the log of x minus the log of y, right? So division becomes subtraction. Okay, and I go over in the video that you watched why this is true. Essentially, this is when we multiply exponents, we add the exponents, and when we divide exponents, we subtract the exponents. So it's kind of connected to your exponent rules. Okay, so that's your two kind of properties we're going to use here. Here's the third one, which doesn't show up in this particular problem, but just to remind you. Okay, if I have something like log of x squared, so if I have an exponent inside of a log, I'm allowed to move that outside and have it be what we call the coefficient, right? I can have it as a number outside. So I can turn this into 2, right? I'm going to take this exponent on the inside. I'm going to throw it out here, okay, and make it a coefficient. So this is 2 times the log of x, okay? And this is actually a property we're going to use a lot. I think next week we'll start using it, right? So this is something that you want to keep in mind. Just doesn't show up in this problem, okay? So these are the 3 properties. And again, they're all reversible. We're going to do the reverse. Oh, no, I'm sorry. We're going to do the forward version, right? So I'm going to look at this problem and say log base 2 of x divided by yz, okay? So I'm going to start off by saying I see a division symbol, okay? And that's this property. So I'm going to split it up first into log base 2 of x minus log base 2 of yz, okay? And so essentially, you're not done expanding unless all of the multiplication, there's no multiplication or division showing up inside of your log. So you can see that I got rid of this division, right, by splitting it up. But this second one now has a multiplication going on, right? So I have to do another expansion using this first property. So I'm going to leave this one and say this is log base 2 of x. And now here's where you have to be careful. Minus, and I'm going to put up a parenthesis because all of this stuff is in the denominator. And I don't want it to look like I am just subtracting the y and then adding the z. I'm really subtracting both because they're both in the denominator. They're both being divided, okay? So I'm going to further split this up and say this is log, oops, can't write today apparently. This is log base 2 of y plus log base 2 of z. Okay, and if you notice now, each of my logs, when we're talking about expanding, each of them now only has like a single component in there, right? There's no multiplication or division connecting them together. Okay, if you want to, okay, and this is entirely optional step, we could distribute this minus sign into both of these and turn this into log base 2 of x minus log base 2 of y, and then if I distribute it to the z as well, it'll be minus log base 2 of z. Okay. So this right here would be now fully expanded. If you left it with the parentheses, that's fine as well, right? Not a big deal. So you can kind of leave it in either form. Okay, so those are the 2 questions that I had. So I'm going to hit the mute button. And if you have any questions, again, you can email them to me if you're not able to get into chat. Otherwise, I will be here for about 20 or 25 more minutes, depending on whether or not we have something going on. Okay? So post any questions into chat, and I will keep going if there are more.